Hello, I'm Dr. John Kruse, and today I'm going to be talking about orexin-blocking sleep agents like Belsomra. Why are they so special? Um, and if I'm grimacing today, I have a herniated disc, so it's not the content that I am grimacing at or you, the audience, so bear with me if I make weirder faces than usual. So I will start, as I usually do, with the take-home message. And the take-home message is that there's a class of sleep medications. The names of those drugs in the US are Belsomra, Dayvigo, and Quviviq, that are working on the orexin system. They are blocking the orexin system. This is a unique mechanism of action, so it is not how most of the sleep agents over the last several decades we've had work. And this means that this class of drugs has a particular lower risk for certain problems and higher risk maybe for others. Overall, these drugs have not, and Belsomra has been on the market since 2014, have not sold particularly well. It's not horrible, but not as well as one might expect, but there is renewed interest, or growing interest. Just this past week, a study was released about using Belsomra, and in just 2 nights of use, they in the cerebrospinal fluid of individuals who are not dementia, but of markers of dementia, so of amyloid beta plaques and of tau neurofibrillary protein tangles within the cells. So those are both decreased at certain time points after taking Belsomra, and that's given that dementia is a huge and growing problem, and the current medications so far are very limited in their ability to do anything. If we had anything that particularly early on could slow the process, that would be great. There's also some interest in a little bit of study on whether orexin blocking agents may be helpful in depression and anxiety and in ADHD. So jumping into it. So what is this orexin system? Most of you may not have heard of it at all. So orexin is a neurotransmitter. 2 different groups stumbled across this in 1998. One group was actually looking at different genes in the brain and trying to figure out what genes were coding for that hadn't already been identified. The other was looking actually at specific receptors where people hadn't identified what those receptors were doing. So the group studying proteins and receptors wound up calling their discovery orexin. So it was found in the lateral hypothalamus, and that was known to be an important center for appetite regulation. So orexin is related to the same word, Greek root, for anorexia, where there's no appetite. So appetite is orexin. The other group named their discovery hypocretin. Hypo because this is again found in the lateral hypothalamus, and cretin because the molecule looked like a somewhat similar molecule called secretin. So officially now, hypocretin is to be used to describe the gene, and orexin for the protein product of that gene. That's confusing, and I think there has been some trend, but not overwhelming yet, of just calling all of it just the orexin system. So orexin is actually 2 similar polypeptides with proteins. There's imaginally named orexin A and orexin B. And there's actually also 2 different types of orexin receptors called imaginatively orexin 1 and orexin 2. Now, it isn't as simple as A binds to 1 and B binds to 2. Both A and B bind to both. So orexin A binds equally to type 1 or type 2 orexin receptors. Orexin B binds 10 times more strongly to the orexin 2 than to the orexin 1 receptors. Again, the cell bodies, this is only a few tens of thousands, 70 to 80,000 cells contain orexin, but they spread, again, like many of the other important neurosystems we've talked about, to all sorts of other areas in the brain, including the dorsal raphe, where serotonin nerve cell bodies are, to the locus ceruleus, where norepinephrine cells are, to where histamine cells are. So both systems, both the distribution of the orexin-1, maybe orexin-2 is more involved in the sleep-wake cycle issues, but that's also not completely resolved. So again, the immediate association with orexin was with systems related to regulating feeding, and it was particularly pro-appetite, pro-food-seeking behavior, and subsequent research has shown that the orexin system is involved not just in feeding behavior, but a whole host of reward-based behaviors, including drug-seeking behavior. So people interested in addiction are looking at this system closely. But the orexin system also is tied into lots of other things. So sleep-wake is another prominent, extensively researched one. And I'll get into more of this in a little bit. So the orexin system is involved not just in arousal or waking you up, but it's also involved in sustaining arousal or keeping you awake. Orexin system is also involved in energy balance. It's involved in attention separate from just arousal. So attention is focused direction of what your mind is paying attention to. Arousal is just whether you're awake or not. And there's also growing research on orexin's connection to what's called hedonic tone, or sort of overall ability to feel or experience pleasure, and a whole host of psychiatric conditions, including depression, including ADHD, have at least a component where it's harder to enjoy things. Part of why many people with ADHD are easily bored. With depression, it goes into full-blown, nothing seems interesting. So again, the orexin system is one of many chemical systems involved in hedonia, or enjoyment or pleasure. So after discovering this natural system in the brain, of course, drug companies jumped in, and the earliest drugs relevant to the system were drugs that promoted orexin or bound to orexin receptors in an agonist activating fashion. And those are the drugs, modafinil and later armodafinil, or Provigil and Nuvigil. I have a separate video on those. I won't go into much of them today. They have been shown to be effective, not just keeping people with narcolepsy awake, but also keeping people awake from a whole host of sleep-inducing conditions. So again, that fits with orexin being not just initiating arousal, but sustaining arousal or wakefulness. And there is pretty compelling evidence that even though it has never been in the US approved for treatment of ADHD, it wasn't because the studies for it showed efficacy for treating it good enough to pass the FDA's rules. There were just some side effect issues that may or may not actually be related. Again, I have a separate video on that. You can go check that out. So separate from drugs that activate or mimic or act like orexin, again, like Provigil, Nuvigil, modafinil, armodafinil, companies quickly jumped in to make drugs that are blocking the orexin system. So and all the three that are on the market right now, they're called the DORA group of drugs. So dual orexin receptor antagonists. So these are binding to the orexin receptor and blocking its action. So if orexin is involved in arousal, then this should shut off arousal. And the three drugs we have in the US market, so Belsomra, which is suvorexant, came onto the market in 2014. Again, all of these are dual acting. They're acting on both the orexin-1 and orexin-2 systems. The one difference among them, Belsomra gets into the brain a little more slowly than the other two, and timing of onset is a separable factor from half-life of the drug. Time of onset is usually related to how fat soluble the drug is. How long it lasts has a host of other factors involved in it. So again, that's a separate phenomena. Belsomra goes in a little more slowly than the other two, so maybe taking closer to an hour to work. Dayvigo and Quviviq probably closer to a half hour for most people for how quickly they work, but how long they last. So Belsomra came out first, 2014. Its half-life is close to 12 hours. Again, and half-life is the time it takes half of it to be gone. That doesn't mean it stops being effective at exactly that time. The end of efficacy depends on what level you need of the maximal dose to still continue to have action. So Dayvigo, also called lemborexant, and I know some of these sound like Game of Thrones characters, suvorexant, lemborexant, daridorexant, was approved. Its half-life is only about 8 hours, and its manufacturers of it claim it's the best or optimal of one's lot. So the longer the half-life, the more you might expect its effects could carry over into the next day. So that's something to keep in mind. But by and large, these are very similar drugs working on the same receptor system. It's certainly conceivable that individuals may have a different response one to the other. But as a group, again, these are quite similar in terms of their behavior. So all of our existing sleep medications before Belsomra came to the market, or almost all of them, worked on the sleep system. These actually are not working on the sleep system. They're working on the arousal system. That may sound silly or semantics, but we know there are two very different systems in producing, sustaining, and maintaining sleep. The other is interested in initiating and maintaining wakefulness. Usually, these are mutually inhibitory systems. So usually when you're awake, that is shutting down sleep. And usually when you're sleeping, it's shutting down, turning off the wakefulness system. So these systems both strongly interact with each other and strongly in a negative way interact with each other. And again, most of our pre-existing sleep agents were sedating agents. They were making you sleep harder, as it were, or pushing the sleep button. Research in the last 2 decades has shown that more than 95% of problems with sleep are not problems with impaired sleep system. They are problems with failure to shut off the arousal system. So on the surface, drugs like the DORAs, the Belsomra, Dayvigo, Quviviq, are a better match for what we need in terms of sleep. So the one way to think of it is that most people with an insomnia problem, your sleep system is intact, it's ready, it's waiting, it just needs that arousal to clear out of the way so it can land and help you start sleeping. Pushing sleep more strongly or strengthening or enhancing sleep, it will get you there. These other drugs work, but it's not an ideally designed system. So those other drugs, starting in the 70s, we had barbiturates, were the main class of sleeping prescription medications. Then we had the benzodiazepines. So barbiturates were things like pentobarbital, almost not used for sleep at all, except in extreme cases these days, because in addition to be sedating to the wakeful, promoting sleep, they also were strong respiratory suppressants. So they were fairly dangerous in an overdose. You'd stop breathing and die. It was a big advancement in the 70s, 80s, 90s when we started using benzodiazepines. So these are the Valium-like agents. Valium, Klonopin, Ativan, Restoril, Prosom, Halcyon. Some of these drugs were marketed purely as sleeping benzodiazepines, so Restoril. Some of them were marketed only as helping with anxiety. Almost all the drugs in this group are equally good at doing both. So it was purely a marketing decision. And part of the marketing decision, I'd say, was fairly silly or stupid. And the temazepam, Restoril, one of the most popular in that group, most studies have Restoril's half-life in the 16, 18-hour range. Why would you want a sleep agent that's going to sedate you half the next day? Doesn't make sense to me. So I'd argue Ativan with a half-life of about, or an effective life of 5, 6, 7 hours is probably closer to an ideal sleep benzodiazepine than other benzodiazepines were. So Problems with the benzodiazepines, though, is that most people develop tolerance pretty quickly. Most people, and addiction also is certainly a possibility with those drugs. There's also something called rebound insomnia. So just a few nights after taking a benzodiazepine, you are measurably, if you don't take it on the third night or fourth night, it is measurably harder to fall asleep that night than it would be if you'd never taken anything to begin with. So that rebound added insomnia goes away after a few nights, but it strongly encourages the ongoing use of benzodiazepines for sleep. Benzodiazepines also, if you take them during the day, and if they're carrying over to the next day, also impair memory. They can impair coordination. They relax muscle tone. They're helpful in some situations, but it makes taking of those drugs predisposes people to falling. And again, I mentioned tolerance, withdrawal, dependence are all fairly common with the pure benzodiazepines. So somewhere in the late 80s, they discovered there are two different sets of benzodiazepine receptors. And the sleep, one receptor is largely responsible for sleep. The other, let's just say, is the anxiety component. And they designed a set of drugs called the Z drugs, or the non-benzodiazepines, to bind to the sleep benzodiazepine receptor. And these were the drugs zolpidem or Ambien, Zaloplan or Sonata, Zopiclone or Lunesta. And again, these were more cleanly binding to the sleep subset of the benzodiazepine receptor. So it's confusing. Some people call them non-benzodiazepines. So benzodiazepine refers to the structure, but they're still binding to the benzodiazepine receptor. The benzodiazepine receptor, as with the barbiturate receptor, is actually a site on the GABA A molecule. So most of our sleep agents and alcohol interact strongly with the GABA A receptor. So the Ambien-like drugs were an improvement over the pure benzodiazepines. There was less rebound insomnia. There was somewhat less tolerance in most studies. Probably less amnesia, confusion, certainly much less muscle relaxation. But they're still statistically associated with higher rates of car crashes, higher rates of falling in the elderly. They are not perfect drugs in this regard. And more of concern, to many people, some evidence, and this is disputed, and there's been very large studies that support both sides of the equation, but maybe an increased risk for dementia for people who take sleep agents of the benzodiazepine or non-benzodiazepine Z drugs over time. So the DORA agents, the orexin-blocking, orexin antagonist agents, seem to be a big improvement in that they are less likely to cause excessive somnolence, sleepiness, sedate, which work better the longer you practice them. But there's some good evidence that the orexin antagonists also work better the longer you keep taking them. The orexin blocking agents seem to do a better job of preserving REM sleep or even promoting REM sleep, which is good for not memory consolidation, that's mostly non-REM sleep, but for integrating experiences of the day into your whole body view or worldview. So why didn't, once Belsomra reached the market, why weren't these huge blockbusters wiping out all their competition? Well, part of it is if you're used to taking something that really knocks you out and sedates you, then you aren't as happy with a drug that isn't as powerfully knocking you out. Again, these orexin drugs are blocking arousal and creating a place for sleep to start. They're not forcing you into sleep, as I would say the other drugs are doing. So many people's clinical experience is, I'm not being sedated enough, this isn't working. Again, giving it more time, and usually giving it a week or two, many people see the effects more clearly. But in terms of sales, they've been somewhat disappointing to their manufacturers. And it's not that they are without side effects. So there is some evidence, particularly at the highest doses with Belsomra, that there may be some impairment in alertness the next morning. There may be some risk for some of the weird sleeping, driving when you're sleeping, eating when you're sleeping, things that are, again, not common, but routinely found in any study that's systematically looking at either the benzodiazepines or the barbiturates or the Z drugs for sleep. So jumping to why I said I'm talking about it this week, and I'll try to get through this really quickly. So there's a strong connection between impaired sleep and dementia. Bad sleep is one of the biggest risk factors for developing dementia later in life. We know that part of this, and that also makes it harder to know whether people who are taking sleep medicines, whether you are seeing those sleep medicines increasing the risk for dementia, or whether it's just the underlying sleep disorder is the problem. Some of the thought is that within the last decade, with the discovery of the glymphatic system, so that's the garbage collection system of the brain that flushes out toxins and accumulated proteins that shouldn't be there, that's a system that only works when you're asleep. But not only that, it only works during nighttime sleep. So it is both sleep-related and circadian-related. So there's studies in rats that are rodents, if you knock out the ability to make orexin, there's actually in a strain of mice that is prone to making. So two of the big problems, as I said, that we've seen with dementia, and we don't know how strongly they are driving the dementia, is accumulation of two bad proteins. One are called beta amyloid plaques, the other are tau neurofibrillary tangles. And if you knock out the ability to make orexin in rodents, or you block orexin with agents like these dual-acting orexin antagonists, you have, in rodent models, less accumulation of amyloid plaques over time. So this most recent study looked at humans, not rodents. They put a catheter into their spinal column to extract cerebrospinal fluid so they could monitor beta amyloid in the cerebrospinal fluid and phosphorylated tau. So when the tau protein gets phosphoryl groups stuck on it, it becomes more sticky and more likely to make tangles. And they studied people for a little more than 2 nights. And at certain time points, there was a direct decrease in both of these, what are thought of as neurotoxic molecules. It wasn't sustained over the whole cycle. These were fairly small, but statistically significant. And the other thing that the authors claim is that because in this study of just 2 nights, there weren't statistically significant changes in sleep, that maybe these DORA drugs are doing something directly to help with flushing out these bad toxins or clearing them out, or having less of them being produced or accumulating. Interestingly, in this study, there were sizable changes in sleep for the better, but they didn't reach statistical significance. So whether sleep is the mechanism by which these DORA agents are helping or not is, I would say, debatable. There's one study looking at ADHD and orexin levels, and that study in children found that the orexin levels were low. There have also been some studies in depression and anxiety looking at connections. And again, because the orexin system's involved in sleep wakefulness, it's involved in motivated behavior, it's involved in attention processes, it's involved in tone, there's reason to believe it may be helpful. And I've certainly seen work with people with ADHD where these agents were particularly helpful for sleep and seem to help strengthen the circadian signal and regularity of sleep in people with ADHD. So that's all I'm going to say today. So again, on paper, the orexin-blocking agents are wonderful sleep agents, and in the real world, people's experiences differ somewhat from how well they are. So, hello, Dennis, again. So Dennis asked, why is Alzheimer's disease increasing in younger age groups in recent years? So part of that is hard to determine whether it really is or isn't. So by that, I mean, today we have a host of blood markers. None of them have been certified as perfectly well marking it. We have PET scans that can be done. We have more ways, we have much more awareness in the Alzheimer's process compared to 20 or 30 years ago. So when we're comparing how common things are now to then, we have much more awareness, much more ability to detect possible changes without having a biopsy done or autopsy done when you are dead, which is still definitively the only way to diagnose Alzheimer's disease. So whether we're actually seeing an increase in younger people or not, I'm not sure all the experts would agree is happening. But if it's going on, one of the most common things are that there are lots of toxic things we're doing in our lifestyles, particularly sleeping much more poorly. And again, poor sleep is a big predictor. It's correlated, again, whether it's causative or not, but it is a strong predictor of who develops Alzheimer's disease or not. There's also speculation that, at the top of the list of recommendations right now for people in the early stages of Alzheimer's, it's trying to get good sleep, but exercise is actually the most consistently recommended intervention, maintaining intellectual engagement, maintaining social engagement. But we know, the Surgeon General, Vivek Murthy, just released a study, loneliness in America is a huge growing problem. We know people are more sedentary. We know they've gained weight. So there's a whole host of lifestyle factors that at least are correlated with developing dementia, and it should not surprise us if we are indeed seeing more of it and more of it at earlier ages. So I hope that addressed that question. I'm not seeing any other questions coming in. I don't have the topic for next week in front of me, but it went out at the beginning of the month. Hopefully I will be in less back pain and making fewer grimacing faces next time. So stay healthy, stay happy, and I will be back next week.